And what we do is we make things real. So everything that you do in the CG world, we like to turn that into real, workable, real-world items. Yes, like I say, we are engineers predominantly, but we really pulled out all the stops with this one to get as many examples and tests done to show you what's possible. So the first question I'll ask is, who's got their own 3D printer? That's quite a few. Have any of you ever had anything printed commercially? Oh, it's good, right. We want to get you all into this game. We want you to use this technology because it's right for your involvement, and every tool that you use in the CG world should be perfectly there for you. Okay, so the question I was going to ask you, if you had anything printed with a manufacturer, is what do they ask for? Every time it's a good or a nice, clean STL, which in some cases is a little bit difficult. And what we've noticed is there's two worlds, essentially. There's the CG world, and then there's the manufacturing world. And there's a dividing line in between the two, which is really only connected by an STL at the minute. We mainly work in SolidWorks and AutoCAD, the industry standard tools. But at the end of the day, the output is always turned into an STL. With this, obviously, we've got a CAD Solid. You can go straight to print, straight to manufacture, and obviously, you know, a CG mesh. So what would we like to do, or what have we been looking at? Well, the idea is, instead of using an STL, which has been around for we'd use an OBJ. That obviously opens up to a whole other paradigm of what's possible. And it means that you have a single mesh geometry. So the same thing that you render is the same thing that you send to manufacture. So a prospective customer can see a product before it's manufactured, but it'll be exactly the same object. It also means that anything in the TV and film, it can be transferred straight the way through, so it's one unified mesh all the way. So yeah, it can go straight into production, straight into render, it can go straight into manufacture, or you can put it into VR or even games. There's also the possibility with other things as well. But the ultra-precise, industrial grade of everything, all it really produces is an STL, which, as we all know, isn't a really nice, clean mesh. So all we end up is with this crappy STL. And the thing is that in the manufacturing world, everyone there experiences the same problems with STLs and meshes. They all struggle with points missing, holes, the lot. And they don't realize the power that Blender has to repair all of these things and really refine and get the accuracy needed for manufacture. So we really want something that's got no limit of resolution or anything like that. So if we look at some STL examples, just a quick example. When we've got thin meshes, the points cross across, and we end up with artifacts. So that's always a tricky one. With no subdivision on the mesh, you obviously can't get that resolution. You can't apply materials to the object. You've got no UV space, so you can't apply textures or anything else like that. And obviously modifiers and everything breaks down with those tri-meshes. And Booleans at your peril with a lot of it. When you've got really simple objects like a hub, this could be something that's really straightforward with a quad mesh. You get this broken down. You can increase the resolution within these programs of the output STL, but it always ends up being that kind of mess. Complex curves, there's a really good example of half a sphere, whereas the outside's perfect, the inside, which isn't a complex curve, we struggle with. And you do tend to get artifacts where bits pinch up and they just move out of place, and it's all a real mess. So what do we really want? we want an ultra high resolution. We want the resolution of reality, if at all possible. We need the next level of Benchy. We need something that we can test and print and make sure that workflow really nails it home. We need quads. That's what we need. It's all good to make you look at that picture. So if only we had a piece of software, this magical piece of software out there that allowed higher subdivision, like I was saying, of infinite accuracy possibly, the remeshing and control of all topology. So if something goes wrong, you can go straight in there and fix it. Freeform sculpting. Something that the engineering world really struggles with is that fluidity that 3D print gives, and we need to be able to do that. We need to maintain dimensional accuracy as well. So we need the print file to fit with any other component in any industry, whatever it may be. We need something that works with every file format, if possible, especially OBJs. Something that can interpret the textures onto that substance, onto the mesh itself, so that those textures can then possibly be printed onto the substance. And it also knows the difference between a sharp and a smooth edge, which is always a problem with 3D print, and, like I say, infinite resolution. So what I'm trying to say to you all is that you all know Kung Fu, that because of Blender, you all have the power to do all of these things, to turn these objects into reality. With every CG mesh that you have, every color and texture that you have, you can use. You're all production level product designers. You've got a greater degree of accuracy with Blender. You've more freedom to create with these sculpted curves and all of these bits and pieces. So you've got more control than CAD designers and CAD engineers at the end of the day with this powerful tool. So you're already Chuck Norris. You've already got those skills. And I'm proud to say Andy is a super ninja, though. But what can you do with these superpowers? There's a lot you can do. So what we're going to try and explain in the future is how we've gone about working with these mesh workarounds, with these retopologizers of the mesh. Whether that be in Blender, whether we're dissolving, redoing the meshes, reducing the number of polys in there, or whether we go straight into ZBrush or instant meshes, that's the one, so that you can really bring the STL in, retopologize it, make it perfect for print. So we'll be looking and sharing that workflow with everyone so that you can all get straight into it. The really key thing, though, with what we've experimented with is the new in-house prototyping or prototyping. And it's all essentially really done in-house now. There's a really simple, straightforward machine, this machine, the CR10, which is only €350, which is, well, as far as we're concerned, really cheap to get into the game. But the things that it can produce are of a high standard, and if you can produce these objects on this machine, you can guarantee that everything you produce there goes straight to manufacture, straight to high-end print in a wide range of materials. The things that you need to note on this, really straightforward, but the key of the game is to stick at it and figure it out. But you've obviously got your bed leveling, your adhesion plate, the extruder itself, and the control of the filament through there as well. And obviously you've got your box of tricks where you can install Marlin in there and really do everything you want. But the idea of this machine is as Blender is, it's the open source machine, and it really seems that lots of people are getting involved with it, trying new things. And the important thing about it is it's got a 30 centimeter by 30 centimeter by 40 centimeter build plate. So you can really print some big things off, which is the same build plate for high engineering. So anything you do there can go straight through. So real world pixels. These are the inks that we use. There are lots of different ones. We've got examples being passed around, but anything you can imagine, really. All plastics are up for grabs, flexible, every color you can imagine. The strength and rigidity of these things is amazing. The finish is really good, But obviously, one of the key things is the ink, and that's why we work with these guys, Rigid Ink, because they're really good at sharing their information. If there's a problem with anything that you get from them, give them a call, and they'll help you figure it out, and that's what we love about Rigid Ink. So, what's the next level? Full color. Like I'm saying, anything that you do within a CG mesh can be pushed out there into manufactured color print. But using the OBJ workflow and the fact that we can texture the object, it opens a whole other realm of things. So you can color objects really well. You can even texture them. You have lifelike instances like this guy at the top. You can have clear things with color in there. The world is your oyster with it. And with your skills and knowledge, everything that you can imagine can be produced on this machine in essence. So what have we done with this? We've got Mamaki. Have a look at that guy on the left over there. And with Andy's wonderful talent, we've managed to produce the agent. Which is absolutely amazing. He's 50 centimeters high, so this thing's got a 50 centimeter build plate, 30 by 30. The world's your oyster. Anything you can imagine, you can do on there. I can't sing Mamaki's praises enough there. Geordie's been brilliant there, the technical team brilliant there, and obviously Andy's model, that thing is amazing. So there we go, meet the agent, there we go. Right, the next thing is really small and accurate. What can you do at a small scale? I'm handing out some samples here now. I can pass these around as quickly as possible. You can go to a ridiculous level. That there on the left is the whistle that we're handing out. Yeah. So who's got a whistle now? You all want to try it? 1, 2, 3. There we go. See, so at that level. So these objects can be as accurate as you want, and they can work straight out of the box with a bit of processing afterwards, done and dusted. And that's at that scale. Digital Metal have been great with us, and they've also got some 1.5 centimeter models of the agent wherever they've gone. We'll show those at the end. Okay, next scale. What happens if you want to go really big? Right. So, the question is, you can see the scale and size and complexity of this. This thing can build to 2 meters high by 1 meter wide. Now, can you guys think of anything we might want to print on there? So what if you want to go big? You can go film scale, print characters and films, print sets from films, do anything that kind of way. Now, we've struggled to get this here for today, but we will be producing a full-sized agent. He's in production now, and that will be something that we share with you all, the whole process, but more importantly, how we've managed to get the fidelity into that object and teach how to deal with scale and the OBJ workflow again. Right, so even more, when we get to metal on a larger scale, we've got Renishaw. These guys produce models on quite a crazy scale. High resolution, not comparable to the smaller scale things, but at the end, please have a look. This uses a solid metal build plate. You've got an SLS system, so solid laser sintering. It can use up to 4 lasers at once on the same build plate, so it can work really quickly. I think you can produce an entire build plate in about 15 hours. So The materials as well, titanium, aluminium, stainless steel, a whole range of things for any application, be it medical, biomedical, or automotive engineer or aerospace. These guys do the lot. But what we're also trying to do is look at how we can test this on an industrial scale. So what we're going to do is work with Renishaw to create one of the objects from our marketing and brand, which is something that we've been working on and which was pushed out of the way for this project. But what we're going to do is print these things in metal to industrial grade, industrial standard, and then we're going to use Nikon, who have a scanner, to really test the quality and dimensional accuracy of what we're talking about with this OBJ workflow. So as an example of the kind of mesh that can produce, that's a scan of a hand. It looks like a photograph, but as you move in, you can really see the fidelity of it. And this is the mesh, the output mesh, which is produced from that scan. So that's the highest level of measuring the distance between those 2 points. And that's something that we'll provide you with information with and get that across to you. Other options of note, plastic is perfect. If it's something produced in plastic in a single color, there's no problem whatsoever. If you can produce that on the CR10 as a standard build, and you've sorted out the way that constructs, then anything you build or want to build in plastic is fine. If you want to have it colored afterwards, that's no problem. You can have it shot blasted. There's so many post-processing things, it is absolutely nailed. It's comparable cost per item to anything you'd have injection molded. It's probably more accurate than that. And you can really push things on. So if you've got this idea of this OBJ file, somebody sees something further down the line, or a customer sees a change they might want to make, that can go straight back into the mesh, and that mesh can go straight into production. So you've got a life cycle of the product, which is vastly increased there with this technology. Resin and UV cured. I haven't covered that kind of thing because we don't feel it's as upgradable as using the filament, the FDM techniques. But it is one of the best options for industrially produced plastics. Other industrial applications, GE have a build plate that is a meter by a meter, well, a meter cubed, 1 by 1 by 1, and in 2020 there'll be a 1.3 meter cubed one, and that's a cowling for a jet engine there. And they already print the fuel injectors for their most recent engine. So, finishing up, we're here because these guys are really interested in you. With the idea of using an OBJ instead of an STL, that whole workflow, it means that they don't have the worries of an STL. So these guys want to print your stuff essentially. You've all got the ability and resources. Nothing's new to you guys with this. You're always pushing the technology that way, and it's something the technical side really do lag behind a bit in, so we really need to push them on. And also we need to show them that this OBJ and this mesh workflow that we use on a day-to-day occasion, that's perfect for the engineering world. We'll be releasing the next level benchy as well, that big boat, so that you can test out your printer and you can test what will go wrong, and we'll show you the ways that you can sort out those meshes. And we'll be working with the industry to make sure that everything you do is dimensionally accurate. And yeah, it'll all work in Blender. Everything that you can think of, it should work in Blender. The last thing to do is talk about what we're doing with this technology. We're producing an arm, which is the thing that you saw at the beginning, so that'll be a full working object using 3D print, hopefully a bit of AI as well in there to make a real world object. And we want to create a superhero, somebody who is a maker, somebody who doesn't have all of these other superpowers, but the power is connecting the minds and the hands together to do something interesting. So please check us out in the new year when we've got everything perfectly nailed. So remember, nothing is impossible with the technology and knowledge that you have. The technology that's out there, it's all up for grabs. So please, please go and play. And if you have any questions whatsoever, just come and talk to me. Last thing is just to say thank you for all the companies that have been involved with us. Mamaki, Geordie's been brilliant. Digital Metal, Tractus, Sander's with us this afternoon. Rigid Ink, Nikon UK, Renin Shaw, all of the crew at Maker Men. Blender, obviously, for being so fab, and Andy for doing the model for us. So let's stop there and just take a look at the models. Thank you ever so much, everyone. Yes.
That's Andy. That's
Is that,
Andy.
well done, Andy. Thank you. Come on, take a look. Take a look.